So question A1. Please take out your calculator. I didn't bring one with me. What is the difference between a scalar and a vector? How many marks for this?
1.
So it should be a short answer.
Yes.
Scalar has only magnitude.
Yeah, scalar has only magnitude. Vector has a magnitude
With direction.
with direction. So
Scalar is just the magnitude.
a scalar,
Is equals to magnitude.
yeah, has no direction.
Direction.
Just a magnitude. Whereas a vector has both size and direction. And, sorry about my handwriting, give an example too. So what's an example of a scalar? E.g. speed. And what's an example of a vector?
Velocity.
Velocity.
Do we have to give examples because it's just one more?
Just in case. No, you don't, but suppose your English was a little bit unclear. If I had an example, I could say, I understand what he's saying. It just helps you to get the mark just in case your English was a little bit unclear. Okay. Right, that was A1 part A, now times B part 1. A boat sails 200 meters directly towards south and then 150 directly towards east in a total time of 80 seconds. So it does this. It goes 80 this way. No, sorry, 200 south, he said, and then east
150.
150. So naturally enough, before I even look at the question, I'd like to get the hypotenuse here. So on your calculator, can you use Pythagoras and give me the, it looks like, is it a 3, 4, 5?
250.
3, 4, 5. 250, yeah?
Yeah.
Now, part 1, oh, and by the way, how long did it take to do this?
80 seconds.
Okay, so part 1 is calculate the average speed. So what's the formula for speed? Average speed?
Distance traveled over time.
Yeah, so average speed is distance over time. So that's 250 over 80. So what's that, please?
Into 350.
Yeah, is it 350?
Yeah,
So-
total distance, right? Total distance.
No, it's 250 because, oh, you're right actually.
Yeah. It goes like 200 down.
See, this is, for me the English was a little unclear. I thought he meant the boat travelled 200 and 150, but not necessarily like that it just went diagonally, but it went down and across. But in fact, I think you're all right. He says 200 south and then 150 east.
Yes.
So yes, thank you for fixing that. So the total distance is
350.
350. Okay, so what's that now? 4.375 meters per second. Okay. Well, B2 is actually what we're looking for. What's the answer? 250. And then part 3? What is the magnitude and direction of the average velocity of the boat during the time? Okay, so, well, we have the magnitude. What's the magnitude? It's 4.375 meters per second. But we don't have the direction yet that the boat basically travelled compared to where it started. So we need to get this angle here. So we should do tan. Tan theta is 150 over 200. So that's right. Tan theta is 150 over 200. Can somebody tell me in degrees, please, what theta is? It's tan inverse 3 over 4. What's that?
It's 6.87.
Okay. So then the direction, which I'll use is this symbol, that equals east, what did you say it was?
36.87.
36.9? Well, 0.9 then? Now, just do you remember this notation? It means start east and then go down. Oh wait, no, sorry, it's the wrong way around. Start south and then go that angle east. You see, because this angle here, I'm measuring it from the south to the east. So that's why I wrote it like that. Yep.
The question, it says like determine the magnitude in the direction of average velocity.
Yeah.
Doesn't that mean they want only the red line?
Yeah. So that are you happy with the angle, the direction?
Yeah.
But not so much with the magnitude.
Magnitude. Wouldn't it be a little bit different from that?
Oh, that's a good point actually. Because the distance is different.
Yes.
Yes, I think you're right. So it's not going to be this. But yes, it's going to be, what's the distance? 250, and what's the time? 80. So what's that now? What is it? 3.125. Cool? Alright. So how many marks is that now?
2, 4,
6. Not bad. Alright. This one here was similar to the other paper I did. You have an object that is rotated in a circle with a constant speed of 4. And the radius is 0.5. And the mass is 2.5. And what happens is it's being swung around in a circle. So there's two times which are interesting, the very bottom and the very top. Let's draw the forces. Here is mg and here is mg. Here is the tension and here is the tension here. Now because it's traveling in a circle, the force must be constant, which means the tension must be changing, because at the bottom, does the tension help?
No.
Sorry, I should say, does it help it travel in a circle? It does, and here it also does. But the gravity, does the gravity help travel, make it travel in a circle here?
Yes.
Well, not really, because it's going in the opposite direction. That's what I mean by help.
Like it's not making it move either this way or that way, because the tension is helping it to move towards you.
Yeah, let me rephrase it this way. For circular motion, where does the force act for a circle? If I had something traveling in a circle, which way does the force act? It always acts to the center.
Yeah.
These two act to the center, right? But here, the gravity does not. So that means the gravity here hinders. That's the opposite to help. Whereas the gravity here helps. So which do you think needs more tension and which do you think needs less tension?
The hinder part.
You need more tension when the gravity is acting against you, and you need less when it's helping you. In fact, it's possible that there might be no tension in the string at the top at all. Because if the gravity was enough, then the string can go loose at the top. But it can't go loose at the bottom. You can't picture that. If you picture something going in a circle, can you imagine it how at the top it could be loose, but then at the bottom it's going to be tight? So the first part is a maximum tension. So which is that, top or bottom?
Bottom.
The bottom. So let's look at the bottom first. So what is the force acting at the bottom? Well, it'll be
Mass.
T
T.
minus mg at the bottom here.
What's the?
The tension. Okay? But because it's traveling in a circle, we can use the formula for force in a circle, which if you want to take out your formula book, is on page 3. Now what information does he give us? Because he gives me the m and the v, which formula should I use? Well, I should use the formula mv squared over r. Or if you prefer, Newton's law tells me F equals ma. And what's the A here from the formula book? Page 3, in the middle. What's the A?
V squared.
Yeah. Okay. Now, what do we know and what do we not know? Do we know the M and the G?
Yeah.
Yeah, and the M
Yes.
and the V
Yes.
and the or?
Yes.
So we have the T. T equals mg plus mv squared over or, which equals m 2.5 9.8 plus 2.5. 4 squared is 16 and the radius is 0.5. Okay, can you tell me what this is? So this is T max.
Excuse me, can you tell me where's the formula for the tension?
Page tension.
Yeah, like
Which formula?
the
Thi-
formula you're using.
This one here. If you look at page 3
Yeah.
and look under the section circular motion and oscillation,
Mm-hmm.
I use the second formula, centripetal acceleration. So all this here is, Bilal, is really just MA. F equals MA. This is the F, this is the M, and this is the A. F equals MA. Yeah? Okay. Who has the T here for me, please?
104.5.
What is it?
104.5.
So if I do 3 significant figures, 105 newtons. Now look, the only difference between part 1 and part 2 is what? When it's at the top, what's the only difference?
The tension and
Instead of minus, it's
plus.
because they add. So rather than rewrite the whole question, I'll just change this minus to plus. So here I get a minus now because it was negative, now it's positive. So when I take it over to the other side, it's negative then. So here it will just be negative that number plus that. So now what is T min? Oh, sorry. What is it? 55.5 newtons. That's okay? Yeah. Okay. A tray. Good old specific heat capacity. You have a kettle, it heats water up, and the water vaporizes. Determine how much heat is needed to raise the temperature to 100. No problem. So, what is the M here?
1.4.
1.4. What is the C?
4,000.
4,200. And what is the delta T, the temperature? 80. You increase it from 20 to 100. And the formula is heat energy required is MC delta T. So that would be 1.4, 4200, 80 equals
470,000.
47,000?
470,000.
470,000. So kilojoules. Cool. Now that's to get the water from 20 to 100. But what happens next? The water changes into steam. And what's the formula to calculate how much energy is required to change the water from liquid to steam? Yeah, it's just simple formula ml. Now what's the m here? He just wants 0.2. And what's the L? It's
2.3 megajoule.
2.3 megajoules, so that's times 10 to the 6. Alright, so what's that then going to be?
460,000.
460,000. Okay. Happy with that? Now, what is part 3? He wants to know how long it would take to do this if the kettle is 2.5 kilowatts. So firstly, we need to know what the total energy is. So just adding these together, and you get, what is that, like 930, is it? Yes, who's that now? That's RWC's, right? Okay. 930. Now, what's the formula for power?
Stephen,
Yes.
I just want to submit it to my active listening because it's due today. I have an excuse.
Now, what do we think, children? Is this a good or bad excuse?
We allow it.
We'll allow it.
Yeah.
You know what the Romans used to do? It's like this or this. So what do we think?
Let's see.
It's,
Who is the emperor?
oh yeah, sorry, I'm the emperor. So let's see. What do we think then? What is it going to be?
No
Yeah.
one else? Okay.
Okay. Be quick.
Oh,
Okay.
yeah.
All right, we'll have your head. Okay, what's the formula for power? No, the general formula. The energy over time, work over time. So what is the power in this question? It's 2.5 kilowatts. What's the work here? 930 kilojoules. And then what's the time?
Time is.
Well, that's what you want to find.
Fine.
So the answer is time will equal 930 divided by 2.5. So what's that? Brandon, what's that?
272.
Excuse me.
Yeah.
This question, it says like assuming no heat energy is lost, calculate how long it take to heat the water to 100 degrees.
Oh, he doesn't want the boiling part.
No, he doesn't.
Okay, so then that means it's less energy here.
Yep. It's only 460.
It's only 460.
430.
It will,
470.
470. All right, well, we'll just change that to 470, and here
470.
470. And sorry, in another version of the paper, he asked the time it takes to boil the steam away. So what's this going to be now?
188.
What is it?
188.
188. So that's seconds. So that's 3 minutes and 8 seconds. Although you can just leave it as seconds. Now, what's part? Actually, that was part B then, not part 3. So then, what's part C?
Efficiency of the kettle is 60%.
Oh, so actually, that A part 2 with the steam, you don't need it again. So if the kettle is 60% efficient, how long will it take? Okay. So what's the formula? Wait, look up here. What's the formula for efficiency? Output over input. And what's the efficiency here? 60. So I'll just write it as a decimal, 0.60. Okay. Now, let's be careful here. What's the output and what's the input? So, for example, this 470, is that output or input? Now, think carefully, what is it?
That's energy.
Yeah, is it the output energy or the input energy?
Output.
It's the output. It's the output. So I have 470 over the input energy equals 0.6. So just across multiply, the input energy
470.
is 470 divided by 0.6. What's that? 783 kilojoules. So now we just do the same thing again, but we need more energy now. Why do we need more energy? Because it's less efficient. So what's the formula? Power equals work over time. So what does time equal? Work over power. So 783 over 2.5. So it should take more than 3 minutes now.
313.
What is it? 313 seconds. Is it exactly 5 minutes?
5 minutes, 15 seconds.
Oh yeah, 5 minutes, 13 seconds. Not too bad. Not too bad.
Can't
So,
we just use this way, like, if assuming 100% efficient, like in the question B,
yeah.
it was 100%. And if it's in C, can we just use the the cross multiplying thing?
Yeah, I think because it's linear. So, I get what you're saying. You're saying that the time in B equals 100%.
Yeah.
So, could you
60.
rescale it to get what
Yeah.
60% is? Yes, but you have to be careful that you don't go smaller. Because if you say 2.5 or 3 minutes equals 100%, then if you got 60%, that'd be less than. Do you get what I'm saying? So instead of multiplying by 0.6, you would need to divide by 0.6. So Brandon, can you take this number here and divide it by 0.6 and tell me what you get?
112.8.
What's it?
112.8.
No, divide it by 0.6. Yeah, 188 divided by 0.6.
313.23. Same.
Yeah, so you could do that.
Because it's just one more shot.
Yeah, okay. I don't. All right, okay.
Take care of time.
Yes. Save those 30 seconds it took me extra. Okay. So how many marks do we have so far? 6, 10, 1, 2, 5, 16 marks. Number 4. Simple
Output.
transformer, primary, secondary coil one. So let's just go straight into this. What is the 240? So that's the input voltage. And what's the output voltage?
12.
12. The primary and the secondary. Now, what's the primary number of turns?
1,000.
1,000. And what does he want?
Secondary.
Oh man, free marks. So the formula is V1 over V2 equals N1 over N2. So 240 over 12 equals 1,000 over
N2.
N2. So I get N2 would equal